Welcome back, guys. So we were discussing about 12 RAG pain points and the proposed solutions with Venchi Glans here. So let's get going. We'll continue our conversation. So welcome back, Venchi and Onkar.
Glad to be here. Thanks. Thanks. It's an honor to be able to discuss with you guys to explore RAG.
Thanks.
Thank you. So we were discussing about chunking strategy, handling different data types, and fine tuning. We were looking at, we have proposed some interesting ways on how to deal with this. These all problems associated, the pain points as you call them, associated with RAG. So moving on, the next topic is on what additional layers can we add to the RAG pipeline. So one of the examples that we tried, Omkar and I tried in our internal use cases, is that we were dealing with a conversational solution, right? So there is a context in the conversation, and when the user asks, say, a fifth turn in the conversation, will not have the complete context of the full conversation. You got it, right? So the fifth turn can tell me more about the process that you have described, or something which doesn't have full context in itself, right? So then the embeddings converting the partial context conversation is going to be difficult. So what we did was we added a layer called context loader. And what it does is every turn it loads the full context of the conversation, and then that loaded conversation is what we send to the LLM for embeddings, right? So that gave better results. So I wanted to understand from you what additional layers like this will help in improving the RAG pipeline. And I see that you have mentioned a few in your blog.
So yeah, there are multiple layers we can add to assist, retrieving the best, more accurate results possible. To start from the query side of things, so query transformation is a big layer that we need to explore further, or when you're developing a RAG pipeline, ensure that you wanted to explore that layer. So that layer out of the box, Llama Index has actually quite a few suggestions. Things like, routing, which is to introduce a layer of routing to sort of direct traffic based on your question and direct it to whichever index is most appropriate. Could be summary index or could be vector index. So, and also there's a sub-question query engine concept. So what that is, it's very good in handling compare and contrast questions. You wanted to compare, let's say, financial reports for a particular company between this year and last year, certain categories. So that is a great way to use sub-question query engine. So the original question gets broken down into two sub-questions. And then each sub-question is handled to retrieve the proper context for the finalized response. So that's, again, another great solution. And then there's recent ones called the hypothetical document embeddings. Definitely suggest to look further into that one as well, because that one, based on your question, it actually produces a hypothetical embeddings for the answer. And then based on that, generated the embedding to compare with the real embedding to retrieve the most accurate context for your question. So these are all very good techniques that we wanted to introduce to our pipeline to ensure the best quality retrieval possible. So that's the query transformation side. And the context loading side that you just mentioned is another, again, awesome point. So like in the multi-turn kind of conversation, to introduce that extra layer to give the most context possible to your LLM to make sure, it generates the best possible answer. And I don't know if we can add, in a way, the re-ranking is definitely another absolute, I would say, implementation you wanted to add if you don't have already. So ensure that we have the best, most relevant nodes get retrieved and fed into LLM for your final response generation. So, and a few strategy mentioned also in the blog.
Venki, regarding ranking, many of the times what happens that our correct answer is not rank 1 but rank 3rd or rank 5th. So you have suggested re-ranker for that. How does it work? So that, and does it help in getting the right answer from, let's say, top k equal to 10 answers?
Yes, absolutely. The experiments have shown over and over, adding a re-ranker to your RAG pipeline absolutely helps increase the accuracy of your, final response. So how that works is you can obviously specify your similarity top K. Let's say if we wanted to specify 5, right? And then 5 nodes are retrieved. And then among them, we go through a re-ranker, like a cohere re-ranker. Re-ranker is a model that it would calculate your semantic meaning. So based on your query and the retrieved nodes, it would calculate and give a score for each retrieved node. And then it would re-rank by ordering the best scored nodes goes first. So let's say if you retrieve the 5 nodes and goes through the re-ranker and it computes your the score for each of the node, and then the top node will be fed into the LLM to get the final response. So adding a re-ranker and also fine-tune a re-ranker model have proven that it always helps with your whole overall performance of your RAG pipeline. So absolutely recommended. Don't skip it. Always add it. That's a good idea.
Sure. And I mean, getting back to the previous topic that I was talking about, adding multiple layers. And in one of the examples, I saw that when you are referring to one question has more than one question embedded into it, like there are a couple of questions or three questions in the same query that the user has asked. And you have mentioned about splitting that question into three and then dealing with each one of the queries separately. Right? Can you throw more light? So, yeah, if you have to build that kind of a layer, how do we do it? Are there any Llama Index or somewhere else do we have out of the box solutions to do that?
Yes, absolutely. The sub-question query engine is out of the box from Llama Index. So I highly recommend check that out. And so how that works is so the initial question comes through, compare, contrast, so and so, right? So the sub-question query engine will break that question into multiple questions for you, and then ask each and every question to get the retrieval and then generation, and then it synthesizes your answer to produce the final answer for you. So that guarantees much more accurate retrieval. So highly recommend you look into that. And the link to the notebook is listed in the blog post. So be sure to check that out.
Sure. Yeah, we'll definitely have a look at it. So I see that the pipeline, the plain vanilla pipeline, definitely for the enterprise use cases is not sufficient. Adding enough layers and on a case-to-case basis is important for an enterprise-grade document search or a RAG solution. That's the major take home after the blog and also during this conversation for me.
Venki, I have some questions basically regarding production deployment. So let's say we have large number of users using GPUs and how to reduce latency and all. Tell something on that.
You mean production deployment if there's the response is getting slow, right?
Yeah.
Yes, because now that we are doing with dealing with so much of additional layers, and of course, the better the model, the better the quality, but adds to the latency, and more layers add to the latency. So, in production deployment, have you encountered scenarios where the latency is one major factor, which is actually a concern to the enterprise? Because of which the while the quality is good, latency is the thing which is not up to the mark. Did you encounter any such case?
Yeah, absolutely. This again is use case dependent. So for production deployment, depending on the documents, your source documents, and a few of the main building blocks of your RAG pipelines, LLMs, the embedding models, the vector store, they all play a key role in the latency or your overall performance of your RAG system. So you wanted to ensure that when you select your stack, ensure that you're picking the best possible for your particular use case. For example, the vector store. So Melvus, for example, it is a GPU accelerated vector database. So, that would definitely outperform the ones that are not GPU accelerated. And for LLM and also the embedding model, you wanted to ensure you try to pick the best possible from the leaderboard. And obviously, it would have to tailor to your particular domain or your industry or your use case. And you wanted to fine tune and ensure that it's able to handle the particular domain specific data that you have for your organization. So all those needs to be taken into consideration. And obviously security is another key point. Maybe we'll touch base in another point here. Yeah, so all of this monitoring, troubleshooting are very important as well. You want to monitor on an ongoing basis to ensure your models, your pipeline function as expected still. I would say start small and iterate. It's a good strategy. You wanted to start with, a smaller kind of implementation and then gradually add on top of the layers. And while you do that, make sure you do evaluation. Make sure that you understand each layer when adding on top of that how well there's always a trade-off, right? Adding the layers would definitely help with your accuracy, better retrieval, but then like the latency perspective, we wanted to make sure that you measure it and you evaluate it and you understand the consequence. And if there's not much of a latency for the particular layer you added, that is great. So definitely have a good sound strategy in place to evaluate as we go and make sure that the new implementation is meeting our expectation while not introducing side effects that's hard to remediate down the road.
Basically, Vanki, I am a bit worried. Currently, we are searching small data set. Let's say one PDF of 10 PDF. Let's say we have large data set, company's whole data set. Then our vector store size will be very large. Our embedding will be large number, millions of embeddings will be there. Then how you suggest to reduce the time required to do the cosine similarity in those millions of embeddings?
Yeah, that's a very good question. I don't have experience dealing with that kind of large data sets, so I'm open to suggestions and, solutions from you guys or the community. But off the top of my head, I would say perhaps introduce, metadata to the concept where we can use metadata to do the filtering, whether it's by daytime or by a particular category or for the particular domain that you're tackling. Just to think from the query perspective, how best you can make sure that your query is not a too kind of broad sense that it would, having to retrieve everything from your source documents, right? So you wanted to make sure you have a reasonably like the scoped down query to ensure that we can perhaps look up the metadata in order to retrieve the right nodes and chunks. That's I would
What could just now I could think on after asking the question is that we can divide our vectors to different clusters and try to find our search in the similar cluster. That can be one thing, so that will reduce our search space. Another thing can be that using GPUs for doing parallel processing, parallel search, that will also help reduce the time.
okay. Yeah, thank you for your input.
So, I was exploring PG vectors sometime back where there are few indexing strategies like HNSW, IVF flat, which help in, they follow K-means clustering kind of an approach where you can get to, instead of searching through each and every index, you can first look at the relevant cluster and then search within the cluster. So those methods are there, and especially for large data sets, I think those kind of solutions would work.
Yeah, good to know.
Yeah, moving on. This is the last section. I think we have already started covering some part of the security and production deployment. This was my last section for today. I have one more point on the production deployment. We are now relying on large language models for embedding creation and for final after retrieving, giving the context to the best model possible to get the best results. That has been the RAG approach. Now, but talking from a production use case perspective, enterprises have their concerns in terms of sharing their data outside their VPC, right? So the questions that I always encounter in when I interact with customers is, can this entire module be deployed inside a VPC? They say that it's okay to have how much ever compute power you need, but it should be within the VPC. Now, for these kind of use cases, what do you suggest? Do you think that it is possible? If yes, how? If not, what are the other ways to mitigate these kind of concerns which enterprises have?
I would think that depends on the models you choose, right? If you're using third-party hosted models, then you can totally deploy it as if it's a regular microservice, for example. So I had a blog talking about the details of deploying to, like for example, ECS Fargate instance for like a chatbot that can handle production traffic. And obviously, AKS Kubernetes is another great option for deploying such solutions. So, is that what you're looking for the answer? I didn't fully understand what exactly you're looking for.
Yeah, the concern that enterprises have is like with the third party LLM providers, say OpenAI or Anthropic, sending the data to these kind of services, servers is something which enterprises are not fully comfortable at this point of time. What we are recommending is like obfuscate or mask the data and then send to LLMs. Or what we are also recommending is these services like we have Amazon Bedrock as a service. They support private link, so the data doesn't go to the public network. It still goes to the server, and they promise that the data will not be exposed, or they will not be using the data for fine tuning their underlying model. So this is the kind of answer I'm giving to the enterprises. Do you think that this kind of a security is sufficient for a production deployment for RAG or similar LLM related applications?
There is Azure OpenAI that's sort of was designed for that, right? This is actually I have encountered the businesses using Azure OpenAI for their to handle this particular concern because let's say for security compliance reasons they're not allowed to share the models with any other organization. So then in that case, the Azure's OpenAI the model sort of privately hosted for their particular use for their organization. Then obviously you have the liberty to use open source models to host it yourself or using third party hosted through any scale and so on. Replicate and so on. So this obviously is another option.
Right. And talking about the same production deployments, there is a major security concern around hallucination, and you have mentioned about that in your blog as well, where you're talking about guardrails, having enough guardrails, and ways, methods to avoid prompt injection. So I see, if you can throw a little bit of light in addition to what you have mentioned, or maybe the points from the blog, that would really help our audiences, because this is one major concern. Hallucination in LLMs is something which I'm hearing a lot from enterprises these days.
Yeah, for that I listed two solutions. So Nemo Guardrail and Meta's Llama Guard. So both of these they can actually work hand in hand. By the way, they're not exclusive. So Nemo Guardrail, from my experiments, I found that it's actually much more comprehensive, and I call it the ultimate LLM security tool set. Why? Because it not just provides input moderation, output moderation, but it can also provide the dialogue rails, which is sort of the bot can control your topic that you discuss, the user discusses with your bot, chatbot. So I feel features like that is extremely very valuable for chatbot. The companies are hosting chatbots. And then you have retrieval rails that can reject a chunk and preventing it from being used to prompt the LLM, or it can alter the relevant chunks. There's another, again, one more powerful one is called execution rail. So that one I actually experimented to integrate with Llama Index from Nemo guardrails. So that worked beautifully with designing a custom action. So you can combine the advanced retrieval strategy from Llama Index and then have it integrated into Nemo guardrail, basically having that rails on top of your the RAG pipeline. So yeah, I would highly recommend you look into implementing that for your RAG pipeline if you don't have any security measure in place already. So that is for sure. Definitely have to look into that. So then the other aspect of it is Llama Guard. So Llama Guard obviously was released by Meta last December, open sourced. It's really a 7B Llama 2 based on that, and added the classifying content for the LMs for both input and output moderation. So that one I have a comprehensive blog and notebooks attached and so on. So highly recommend you look into that as well. So the flexibility of those is those both of Llama Guard and Nemo guardrails is that they allow you to customize based on your domain, based on your industry, what type of prompts that you wanted to reject or, to moderate. So you can customize that. Like in the case of Llama Guard, you can add additional custom taxonomy to add additional like unsafe categories. So it comes out of the box with 6 unsafe categories, and you can, modify those, or you can add additional ones to ensure that the prompts coming in, they're being properly moderated before it gets fed into LLM, or the LLM's output before it gets output back to the user. It goes through this filtering by the security measure here through these models, that it can ensure that the model is not outputting any toxic content back to the user. So it can have a layer of protection. So definitely highly recommend you guys look into that if you haven't already.
Yeah, we have been working primarily on input rails and output rails, part of a few of our pilots that we are doing. And the additional things like execution rails and retrieval rails, dialogue rails that you have mentioned are really, I mean, something new that we have encountered as part of the block. So I see a lot of value in exploring more. And as you have mentioned, yeah, so this Nemo guardrails and Llama guard is something which definitely would add a lot of value for the implementations that we are doing. Thank you for.
Yeah, both of them are open source, so definitely feel free to explore. And the source code is totally there in the public GitHub repos. And if you certain areas don't fully understand, dive into the source code and check them out.
Sure, yeah. And this brings to the last question of the conversation today, which is again related to the deployments. I see that especially for enterprises, there are few turnkey solutions out there in the market. Amazon Q being one in the news recently. Starting December, there's a lot of buzz around Amazon Q, which helps in solving enterprise document search problems. It's a turnkey out of the box solution where you can upload documents and get the results out easily. And on the other side, what I heard from you is like not all size fits all. So everything looks like a custom implementation when it comes to RAG. So these are the two different school of thoughts I'm encountering, and want to understand your view. Like how what do you recommend for enterprises? Do you recommend a turnkey or a custom solution for document search?
Yeah, I would say again that's use case dependent and your industry dependent, because for certain industries it's not possible to use Amazon Q for your production grade chatbot for security and data privacy concerns. So those are for obvious reasons you just cannot upload your production data into turnkey solution like Amazon Q. But for other industries, for example, like if you don't have too much of regulation or compliance in place, that you probably can consider and doing a POC and test it out and see how that works for you. Obviously, the factor is complexity of your use case, right? For simple applications, you may want to try Q for POC and see how that works. But for complex and specified customization requirements, I doubt Q will be able to handle all your customized requirements. So in those cases, you'd better just build it from scratch, or use really nowadays use frameworks like Llama Index, for example. They have this CLI to create the Llama, and just by running one line command line and then go through a few prompts, answer a few questions, you will be able to stand up the boilerplate microservice for your chatbot out of the box. So the development is really simplified now with so many tools and the tool sets and all the bells and whistles in place. So absolutely dive in and check that out. It's not that difficult. The last point I wanted to mention is obviously budget constraints. So Amazon Q, you obviously have to pay. If you use that, have to pay on an ongoing basis. But if you have your customized solution, then it's up to you. Like, how do you want it to, set the cost and so on and so forth, or whether serverless and so on to even save more cost. So those are all I would say, key factors you wanted to consider.
I want to ask is that while using Amazon Q, they might be using a large token size model. And does it help if we are using a token size of let's say our chunk size has is let's 126K? What is the impact on RAG result, RAG accuracy? Can you suggest?
You obviously wanted to make sure you pick the right model, has the right, the context window and so on to handle your particular workloads and your use case. So that is, I would say, in your LM selection or your embedding model selection phase, you have to take those into consideration. making sure that you're picking the right model. If you
I'm just guessing that Amazon Q might be using large token size LM, and result might not be as good as using different techniques that we discussed today.
I would definitely say, do a POC and build one for yourself and compare the results by Q and by your own RAG pipeline and see how that works.
Great. I think that brings to the end of the episode on 12 pain points in 12 RAG pain points and the proposed solutions. And to quickly summarize, we got to understand what different chunking strategies are there. How do we get to the right set of hyperparameters? How do we deal with the data in the form of tables? How do we add multiple layers for RAG performance? What are the security and the prompt injection challenges? How do we deal with guardrails? How do we deal with production deployments? A lot of interesting topics I believe we have covered, and thank you very much, Venki, for your time and the effort that you have taken.
Sure, sure. It's my pleasure. Really great. Learned a lot from you guys too. So appreciate it.
Thank you very much, Venki, for your time and effort that you have taken.
Thanks.
Thank you all. Have a good day. Bye.